Hello friends, in the previous lecture we have got to know about what is actually common ion effect, and now we are going to study about what is the effect of when a weak acid is been dissolved with that of its salt, and regarding what is the common ion effect that it can be shown. So let us talk about it. So now we are going to talk about basically the common ion effect on dissociation of a weak acid in presence of its salt. So since we are talking about the weak acid, this is the example that we have took in our previous lecture also when we are discussing about the buffer action as well as the acid in buffer solution. So suppose we are taking a weak acid and a solution, it consists of a weak acid along with that of its salt, and we know that when it comes to the weak acid, we take an example, that is acetic acid. And since it is a weak acid, it will dissociate incompletely into, that is, or it will dissociate partially into, that is, acetate ion along with that of the H plus ion. So that's the reason that it is been called the weak acid, because if we are taking 1 mole of, that is, acetic acid, so we can't get 1 mole of H plus ion, because even though if we get 1 mole of H plus ion, again it has a capability to, that is, to combine it again as CH3COOH or acetic acid. So for example, suppose if we are giving a salt of that acid, that is a salt of acetic acid, suppose that is basically sodium acetate, which is this one. And since it is a salt of the weak acid, so therefore because it will dissociate completely, so therefore we could get, that is, CH3COO minus, that is acetate ion along with that of Na plus. So this is what we have got. But comparatively, if we see that the acetic acid that dissociates to a particular extent so as to form the acetate ion along with that of, that is, H plus ion. But in that solution, suppose if we are adding the sodium acetate, then we could see that the concentration of, that is, the acetate ion, it goes on increasing. And that's the reason in the product side also, if you could see that the concentration of the that is the acetate ion, it goes on increasing. So according to the Lee-Chatelain principle, as we know that so as to reduce the stress from this, so what will happen is the reaction will move from the right to the left, and that's the reason that what I am saying is the equilibrium will shift from right to the left side. And in this case, we could observe that since the concentration of, that is, the acetate ion is more on the product side, so therefore to maintain the equilibrium, so therefore it will shift the equilibrium from right to the left. So in this case, we could see that the combination of CH3CO, that is the acetate ion, along with that of the H plus ion, it will go on increasing, and that's the reason that we could find that the acetate ion is now been converted into the acetic acid, that is CH3COOH. So now initially what it used to happen that the acetic acid, it used to get dissociated, but because of the common ion that we have added, because of we have added the common salt, that we have added the salt, that is sodium acetate, so therefore because of the increase in the concentration of the common ion that we could see over here, so therefore we could see, we could observe that the concentration of the acetate ion, it goes on increasing, and that's how we could suppress the dissociation of the acetic acid. And this is because of the common ion effect that we have got to know. So this all implies to the common ion effect along with that of the principle, that is Lee-Chatelain principle, and that is how the dissociation of the weak acid that can be compressed. So if we could observe that since the acetic acid won't be able to dissociate the H plus ion, so therefore we could say that whenever an acetic acid will dissociates into its respective ions, the concentration of H plus ion goes on increasing, because only if we are talking about just acetic acid. So in this case, obviously the pH will go on decreasing. But what if we have added the sodium acetate? So in this case, what happens is the H plus ions, which was free when it was been dissociated from the acetic acid, now it will be combined with the acetate ion, and again it will form, that is, acetic acid. So in this case, we are saying that the H plus ion concentration that goes on decreasing. And if the H plus ion goes on decreasing, the concentration of H plus ion that goes on decreasing, obviously we could see that the pH level will move towards away from the zero, and that's the reason that the pH value will go on increasing. So up to a particular limit, it will go on increasing, and that's the reason that in this case, since the pH is more than the expected, then we could say that there is a presence of the weak acid, and and that weak acid is basically acetic acid. So therefore, this common ion effect plays a very important role in not just only suppressing the dissociation of that particular acid, but also has an influence on the pH. And that is what I wanted to talk about when there is presence of salt. So that's it that I wanted to talk about. So thank you friends for watching this video. I hope you have understood this video very clearly and you have got to know various facts about this thing. So share this video with your friends and yes, don't forget to subscribe. Ekeeda channel. Thank you so much.